Alright, so what we're going to do is we're going to take those properties that we learned last section and now kind of use them to solve equations. Alright, so exponential equations are equations where the variable occurs as the exponent. Our main goal is to get the x out of the exponent so that we can solve for it. So the first way that we're going to talk about is trying to get the bases the same, or we can abbreviate it with that. Right? So it says if you have the same base to each other, right, what I can do is that I can set the exponents to each other. Right? So if I have, say, something like 2 to the x is equal to 2 squared, right? I have the same base, right? So based off of this, their exponents must also be the same. Yep. Right? So that's what we're going to try and do. We're trying to convert the bases so that they are the same on both sides. So it's going to take a little bit of rewriting, but our ultimate goal is to get the bases the same so then I can set my exponents equal to each other. Alright, so to solve each of the following by getting the bases the same. Okay, so I have 8 to the x is equal to 2 to the x plus 6. Alright, so again, what I want to do is I want to try and get this base and this base to be the same. Right? So I can't really break down 2 really much more than that. Right? But how can I write 8 so that it is in terms of 2? Right, good. So I'm going to rewrite 8 so that it is 2 to the third, and then I'm going to leave the x on the outside, and that's equal to 2 to the x plus 6. Right, so all we're doing is rewriting. We're still keeping everything the same, right? 2 to the third is the same thing as 8. Right? Now using my properties of exponents, this left side here turns into what? No, I don't want to do that. Right? I have an exponent, right, raised to another exponent, so I can multiply them together, right? So then this is going to become 2 to the 3x is equal to 2 to the x plus 6. All right? Now that I have my bases the same, right, my exponents must be the same as well. So I have 3x equals x plus 6. So I have 2x equals 6. So x must be 3. Right? So this method works really good if you have one exponential equaling another exponential. Does everyone see how we got 3? Does that make sense? All right. Okay, so I have 100 to the x is equal to 1 over 10 x minus 3. What base do both of these have in common? 10, right? So, base 10. So, how can I rewrite 100 to the x so that it has a base of 10? So, like, what is 100 the same thing as? 10 squared, right? So I have 10 squared to the x, right? And then 1 over 10 is the same thing as what? 10 to the negative first, right? Okay. So now that I have, I want to simplify a little bit more. So 10 squared to the x, right? If I multiply those exponents together, that gives me 10 to the 2x, right? And then the other one gives me 10 to the negative x plus 3. Right? Now that your bases are the same, what can I set equal to each other? Right. 2x equals negative x plus 3. So I can add the x over. X must be 1. Not too bad, right? All right, what about C? Good, I want to use base 3 on both sides. So if I rewrite 9, right, that's 3 squared. So I have 3 squared to the 2x. And then if I rewrite 27, 27 is what? 3 to the third. And then x minus 1. All right, so I have 3 to the 4x is equal to 3 to the minus, good. So that gives me 4x equals 3x minus 3. So that gives me x equals negative 3. Whose phone do I hear? All right, now we have D. So I have 100 times 1 over 5 is equal to 4. Is there really any base that they all have in common? No, right? So I'm going to have to do a little bit more algebra. Okay, so if I did that, no, I can't do that. If this wasn't here, then yeah, you could distribute, but because it has the exponent, you can't like distribute it like that. It doesn't work that way. Could I? What's the 100 and the 1 to the 5th x over 4? What are they doing with each other? Multiplying, right? So if I wanted to get rid of the 100, what could I do? Divide, right? So if I divide both sides by 100, right, that's going to give me 1 over 5 to the x over 4 is equal to 4 over 100 becomes what? Right. All right, now, does 1 over 5 and 1 over 25 have a common base? 5, right? I could do that. Or, what's a way that I can take, sort of. So, like, if I take the, like, what would I have to do to 1/5 to give me 125? Square it, right? So So I could have 1 over 5 x over 4 is equal to 1 over 5 squared, right? So now they both have a base of 1 over 5. So now I can do x over 4 is equal to 2. So my answer would be what? 8. Good. Not bad, right? All right, so the other way that you can do it is if you have, we kind of talked about it towards the end on Friday, is if you have an exponential, and what you can do is you can take the log on both sides, right? So if I had, say, something like 2 to the x is equal to 10, right? And I wanted to get the x just to be by itself. So what operation cancels out this base of 2? So what is like the inverse of an exponential with a base of 2? Say again? Not square root. Log of what? Base 2, right? So if I do the log with a base of 2 on one side, and if, again, what you do to one side, you have to do to the other, right? So what happens is that log base 2 and that 2 cancel each other out. So x would be equal to log base 2 of 10. And then you could plug that into your calculator and get the answer. All right, so if you can't get the bases to be the same, you could use logs to help you cancel out certain things. All right, so solve each of the following using the logarithm method. Give exact 3 decimals if necessary. All right, so if I have 2 to the x is equal to 7, is there any way that 2 and 7 have the same bases? No, right? So what's going to help me cancel out? Right. So I have log base 2 of 2 to the x. Now again, what you do to one side, you must do to the other. 7. Right? Log 2 and the base cancel each other out, and you're left with x equals log base 2 of 7, which is roughly what? Now, if you guys have the newer calculators, you can just type it in like that. If you hit the math button and then go down to the bottom where it says log base, you should be able to type it in like that. But if you have the older one, how do you have to type it into your calculator if you have the older version? Right, so you want to do log of log of 7, and you're going to divide that by log of 2. So if you have the newer version, you can just hit the math button and then go down to the bottom and hit log base, and you should just type it in like you see it on your paper. But if you have the older one, you can just hit log of 7 divided by log of 2. All right, so you always want to do 3 decimal places, so 2.807 would be your answer. All right, so does everyone see the algebra there? This is all right. If you didn't have a calculator, you could just leave it like that. All right, but if you have a calculator available, you can get the exact answer. All right, so you have 5 to the x minus 2 is equal to 200. So can I raise 5 to some power to give me 200? I don't think so, right? So I can cancel out the base, right, by taking log of 5 on both sides. Right, and then what am I left with on the left side there? Okay, which is equal to log of 5 of 200. So x must be equal to log base 5, 200 plus 2. And that would roughly be what? No, because like this is one answer, log of base 5 of 200, and then you're going to add 2 to that. Like if this was log base 5 of 200 plus log base 5 of 2, then yes, you could put them together, but they're separate. You can't really add them together. So five of 200 and then plus 2. So my answer is 5.292.